Hey guys, Mr. Gran. This is FST 8.2, multiplying and dividing rational expressions. In this video, we will be simplifying rational expressions as well as identifying the values for which the expressions are undefined. So, quick property to start with. Remember that a rational expression is undefined for any value of x which makes the denominator equal to 0, right? So basically any fraction where the bottom of the fraction is equal to 0, doesn't matter what the top is, this is undefined. So not only are we going to simplify these rational expressions, but we're going to figure out what their domain restrictions are. All right, this is an example of the type that we're going to be looking at in this video. Where you have a factorable polynomial as both the numerator and the denominator. We're going to be factoring them, canceling the common factors, and figuring out what values of x make that denominator, the bottom of the fraction, equal to 0. Now, before I take on this one, a couple of things that I want to go through. We're going to be canceling factors, and there's a really common mistake that students make. Now, I want you to think about, would it work to do this? So I made it 2 plus 1 over 3 plus 1. Would it make sense for me to just cross out these 1's and say that this is equal to 2 over 3? Well, hopefully you said no, because 2 plus 1 over 3 plus 1 is equal to 3 over 4. So if we do this correctly, plus 1, it's 3/4. We can't cancel them out if there's a plus or a minus in between. If it's the whole factor that matches, then we can. So on something like this, would it then make sense to cross out the x and the x and just say that this is equal to 2 over 5? Well, of course not, right? This is what students try to do, and that is fake math. It's not real. Crossing this out, saying this equals 2 over 5, what that's implying is that it's always 2 over 5 for every value of x that you plug into it. Well, if I plug in a 0, that works because it's 0 plus 2 over 0 plus 5. But if I plug in a 1, right, well then it's not equal to 2 over 5. It's equal to 3 over 6. So that doesn't work. Please don't do that. Okay, some basic steps that we can follow when we're canceling factors. We can only cancel factors, like I was saying, nothing that has a plus or a minus between them. So what we are going to do, the steps for this, one, we're going to factor when possible. Most of these, both the top and the bottom, are going to be factorable. Some of them just one or the other. Our methods of factoring: GCF, difference of squares, your basic trinomials, your sum and products, also your voodoo or slide and divide. Once we have them factored, then we're going to cancel out the common factors. And then the third step that I didn't make it into the PowerPoint for some reason is we're going to list our domain restrictions. Basically listing what are the x values that make the denominator equal to 0, and therefore the whole thing is undefined. All right, so going back to that first example. Taking on something like this. We're going to start out by factoring it. Basic trinomial, sum and product, what multiplies to a negative 2 adds to a positive 1. Remember, if there's no number in front of the x, that number is 1. So those two numbers would be plus 2 and minus 1. In the denominator, two numbers that multiply to negative 3 add to a positive 2 are plus 3 and minus 1. Well, now we have a matching factor. This is what I can cross out. I can't cross out the x squareds and cross out the x's and maybe cross out those 2's. You have to factor it first and figure out what are the factors that cancel. So the x plus 1's cancel out, and this simplifies to x plus 2 over x plus 3. Now, what are our domain restrictions? What can't x equal? The denominator, this part of this polynomial is equal to 0 for whatever x values make these two factors equal to 0. Well, this factor is equal to 0 at -3, right? -3 plus 3 is 0. And this factor is equal to 0 at +1. Now, even though that canceled out, it's still part of the original. And so because it's part of the original, it counts for the domain restriction. It doesn't matter if it cancels out, it still counts as the domain restriction. All right, now here's a few examples to, if you feel like you got this, you can pause the video, give them a try, and then resume the video when you're ready to see these ones done. Check your work. All right, so this first one multiplies to -3, adds to -2. That's -3 plus 1. Multiplies to 4, adds to 5. That is +4 plus 1. So the plus 1's cancel out. That means our answer, x minus 3 over x plus 4, and our domain restrictions are -4 and -1, like that. This one multiplies to a -3, adds to a -2. We just did that, -3 plus 1. And then the denominator multiplies to -2, adds to a -1, right? If it's minus x, that's minus 1x. And so that's going to be x minus 2, x plus 1. That's going to give us x minus 3 over x minus 2 for our simplified form. The x plus 1's cancel out. What can't x equal? A +2 for the x minus 2 and a -1 for the x plus 1. All right, over here, we've got a couple of difference of squares. Two numbers that multiply to -4 but cancel each other out. That's going to be +2 and -2. And it's all over x minus 2. Now this one didn't factor, but that's all right. I can cancel out this x minus 2 with this x minus 2 because the whole factor matches. All right, so what's left over? X plus 2. Everything in the denominator canceled, so that means the denominator is equal to 1, but we really don't write that if the denominator is 1, right? Like you could write it like this, but we normally don't. And then our domain restrictions, or restriction in this case, x can't equal a +2. And then our last one, x squared minus 36. That's going to be +6 minus 6 for our difference of squares. And then the denominator multiplies to a +36, adds to a -12. That's going to be -6 minus 6. Now, there's two x minus 6's on the bottom, one on the top. Only one is going to cancel, right? Don't cancel everything from the bottom. It's just one cancels one. And so what I'm left with is x plus 6 over x minus 6. And our domain restriction, both of the factors equal 0 if x is +6. So that's our only domain restriction.